I'm going to talk about gas laws and some of the things that affect gases, starting with kinetic theory. It's the top part says list things you know. You don't have to do that. The kinetic theory of gases is that gases are in constant motion, that gases have a very, very tiny volume, so they can be smushed together, and they move so fast and they're so far apart they don't attract each other. So I have a PowerPoint that is going to lead us through this, and we're going to start with, under kinetic theory, the first property of the kinetic theory is gas particles are so small that the distance between them is assumed to be insignificant. All right, that means they just don't take up much space. So this explains compressibility. I'll go back to that other one so that you can pause it and write down what you need to write down, I guess, and that would be what it explains. The second property, no attractive or repulsive forces exist between particles, meaning they are so far apart they are not attracted to each other. Now, this is in ideal gases, and there are situations where these things don't hold true. The result of this is the gases are free to move in their containers. The third property, gases move rapidly in constant random motion. And they are affected by temperature and pressure. All right, if you have a smaller volume, you're going to have more collisions in a container, and the particles will obviously be closer together. If you have a larger volume, you'll have fewer collisions. I also want to talk about what I just said, what we're talking about. This is true for what we call ideal gases. And we have a law called the ideal gas law that you will learn. However, this breaks down at high pressure because pressure is a force that is exerted on an area. So if you have a high pressure, that means you're compressing something and the particles are going to be closer together. So that third property, or that first property, that they're far apart, and that second property, they don't affect each other, well, we've just brought them close together in a high pressure situation. So it breaks down under high pressure. The other thing that's going to bring them closer together, that it's going to break down, is low temperature. So if you're talking about gases, the kinetic theory holds true for most all gases, but if you're at high pressure or low temperature, you're going to have some issues. Now, how do we describe these? I'm going to go back to the PowerPoint. We'll just go in order. The effect, variables used to describe gases. Pressure is the first one, and pressure is measured in atmospheres, but it can also be measured, and I think I can write on this with my pen, yeah. It can also be measured in torr, in bars or millibars, pascals or kilopascals, and millimeters of mercury. I'm going to put in the classroom file a video for you to watch about barometers. A barometer is what we use to measure the pressure, air pressure, and it's just the amount of air that's pushing down. Normal amount of air, this is another one you could use to measure, is pounds per square inch, meaning how many pounds are on 1 square inch of your body. And I believe it's 14 psi that the atmosphere enacts on our bodies. So if you have a square inch drawn on your skin, normal atmospheric conditions, there's actually 14 pounds of pressure pushing on that. That's why when people go out into outer space, they have to wear pressurized suits. If they don't, then their blood vessels are going to swell because there's not that pressure pushing down on them. Great James Bond film where they kill the guy by increasing the pressure and then lowering it, and he blood all over. It's really great. All right, so watch that barometer video when you get a chance. Variables used to describe gases: the temperature we measure in Kelvin, and we measure with a thermometer. When we started the thermochem unit, I put in the stream on Classroom a video about how Fahrenheit came up with the idea of his thermometer and measured the thermometer. So you might refer back to that. We learned about Kelvin, we learned about Celsius, but when we're measuring heat, we're measuring a change in temperature, and Kelvin and Celsius degrees are the same size, so it's not so important that you measure in Kelvin. But in gases, you have to convert to Kelvin. It has to be in Kelvin because there's a relationship between volume and temperature, and temperature, if it's negative, means that volume could also be negative, and you can't have negative volume. So you have to change to Kelvin. Very important. We don't use Celsius. All right, variables used to describe gases. The third one is volume. We measure it in liters. You're going to probably have to change everything to some cases you can leave it in milliliters or cubic centimeters, but just remember that 1 milliliter is equal to 1 cubic centimeter, and that there are 1,000 milliliters in 1 liter. All right. The fourth variable that we'll talk about is moles. This is amounts. And to me, this is really self-evident because you've all blown a balloon up before. The more air you put into the balloon, the bigger the balloon gets. So there's a relationship there between the particles and volume that you can document. All right, another thing we talk about, standard temperature and pressure. You want to have something to compare to. And so scientists have declared that 0 degrees Kelvin, or 0 degrees Celsius, 273 Kelvin is our standard temperature. And 1 atmosphere is our standard pressure. So those are things you're going to see. It'll say a gas at STP, and if it says that, it means that it has 1 atmospheric pressure and a temperature of 273 Kelvin. All right, Boyle's law, Charles' law, and Gay-Lussac has already been addressed. That video is a separate video, so you can watch that. But this should take care of pages 3 and 4.